Hi, let's solve the third question from today's weekly contest, that is maximum palindromes after operations. So in this question we are given zero index string array words which has length n, and basically we are given words array in which n strings are given, and then we can perform this operation any number of times. So the operation is I can choose any four integers and I can swap the characters at words of ix and words of jy, which basically implies that I can take any two strings and even the one string, and I can take any two characters, right? Any one character from two strings or any two characters from one string, and I can swap them, right? So basically it means that I can take, let's say I take these two strings and I can take any characters among these strings and I can swap them. So that is one operation. And or I can even do this, I can choose only one string, and in this string I can choose two characters and swap them. Okay, so now we understood what the operation is. Doing this operation any number of times, I have to maximize the number of palindromes words can contain. Okay, so let's understand what the question is. So we are given these three strings. I'm taking the first test case, and we are given, okay, these are the three strings we are given, and we can perform the operation any number of times. Now the way the operation has been written, um, it means that I can take any two strings or even one string, and I can take any characters and I can, swap them, which basically means I'm free to do anything with these characters. It's just that I cannot change the length of the strings given inside the word array, but I can change any of the characters here, right? And I have to make the palindrome. So in this question you have to first understand a few things, right? So that first thing is, let us first see what the answer will be here and then we'll discuss. So here if we can get a somehow here, right, then I can make this a palindrome. So let's say I swap this B with this A. So what will happen? This will become BB, this will become AA. Now I can see this is the palindrome, this is the palindrome, this is the palindrome. So on performing only one operation, I'm able to, maximize the number of strings, palindromes here, right? So the answer here is 3. So one thing is very clear, that the maximum palindromes can be the number of strings given. So the answer would lie between, so let's say this is the answer and this is the range for the answer. So answer can be from 0 to n, anywhere, right? Only this will be the number of maximum palindromes. All right. So as I said, we have to, take note of a few things and we can form the answer, because we do not actually need to care about the characters that we have. Okay. So what is the first thing that I want you to observe, right? So the first thing is, first of all, what is a palindrome and how palindromes are formed, right? So palindrome is nothing but if you read a string from in the forward direction and in the backward direction, the strings you get must be the same. So which basically means if I read this string like this, so I get A B B A, and if I read this backwards, that is A B B A still. So this is a palindrome. So that is the definition of a palindrome. Now string length can be even or odd, correct? Let's say if the string length is even, so that means I will have some even spaces to be filled with characters. So the only thing I need to observe here is that these characters that I'm about to fill here, they must be appearing in pairs, correct? So that means I will fill this character and these characters, because I want to get the same character if I read it backwards or forwards. Similarly, I'll fill this with one character, right? This should be the same character, this should be the same character, and so on. So in even length palindromes, the frequencies are always even, and all these characters must be appearing in pairs. So frequency is even. But what would happen if the string length is odd? In that case also, we would start filling in the same way, but there would be one character where we would be left out. So I'll fill this, I'll fill this, I'll fill this, but this one character is left out. Now what am I supposed to do with this character? So I can fill any character with odd frequency here, correct? So because other characters are needed with even frequency, right? Other characters are needed with even frequency, so one character which has odd frequency I can fill here. So that means all the characters in odd string also must be appearing in pairs except for one character which we can place in the middle, which is allowed to have odd frequency. All right, so this is the first observation that we want to do here, right? So now using this observation, what I can say is, what I'll do, I'll take these characters in a container, right? And what I can do is I can have these blanks here and I'll try to fill these blanks. So let's say I place all these characters here. So I need to know how many characters we have, right? So A character appears 4 times and B also appears 4 times here, right? Now I would start filling these strings, right? As I said, I want to, fill with pairs, right? Okay. Now from where do I start? Do I start with this string, or this string? Obviously, I would say from the smaller string, because we want to maximize palindromes, right? So let's say if I consume these characters here, and after consuming these characters, I'm left out with odd frequencies, so I'll not be able to fill out these, right? So that means I get only one palindrome as a result. But if I had used these characters to fill in smaller strings, then I would have gotten two palindromes, right? Let's say I'm able to make this one a palindrome. So I can take these two characters, fill here. Sorry, these two characters fill here, these two characters and fill here. So I will get two strings, right? So that means I need to consume these pairs starting from the smaller strings, right? So that is my first observation. Okay, so what I'll do, I will take, let's say start with A. So I will take A in pairs. So I consume 2A. Then let's say I take these 2A here as well. So this will be the answer. Now I have consumed A character completely. Now I'll come to B. I have 4 and I also have 4. So I'll just simply fill these characters here. So you can see I have now formed the palindrome. So this is also a valid way of forming palindromes, and this gives me a generalized way in which I can solve the problem. Correct? So this is exactly what I'm going to do. I'm going to take all these strings, frequencies, and I'll store it in my frequency array. After doing this, I will also take the lengths of these strings, right? Now here it was pretty easy. Now in the case when we have odd frequencies, what would happen? Now let's say we have some strings here. Let's say I have some strings here. So what I'll do, I'll start with this string. Let's say I'll put some element here. I will then go to this string, put some elements here. I'll go to this and put some elements here. All right. Now I'll come here and put some elements here. Okay. Now the catch is, let's say I have number of odd length strings I have is, let's say, 5. Okay, and the number of odd frequencies I have is, let's say, 3. Then what would happen? What I would do then is, I'm saying the odd lengths are 5. So let me make that. Let's say I have these. Okay, so we have odd length strings as 5 and the number of odd frequencies as 3. So first what I'll do is, the characters which appear in pairs, I will put them here. So I'll first take all the characters and form pairs. Then I will be left with some other characters, right? So other characters, what I will try to do is, I'll try to fill those characters first which appear in odd frequency. So I'll fill it here, 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 and so I only have odd frequencies as 3, right? So these odd frequency, after we consume all the pairs, right, we will be left with 1 1 1, right? So let's say A, B, C were the characters which were appearing in odd frequency, but still if we have 3A, I have one A pair, right? And in last, one A will be left. So what I'm trying to say is that I consumed all the pairs. I consumed all the pairs here, right? After consuming all the pairs, now I am left with 3 of odd frequencies, and there are only 1 1 characters that are left. So what I can do is, I can take all these characters, I can take all the odd length strings, and in the middle I can place these odd frequency characters. So now these odd frequency have reduced to 0, and the number of string in which the length is 2, odd length are 2. So now I can take the character which is, appearing 2 times. So I will place one character here and one character here. So that basically means that I have consumed all the odd frequencies and all the odd lengths, and hence I have gotten a number of palindromes, right? So I hope you are getting this, right? What I'm trying to say is we are having some characters with some frequencies, right? And I am checking, I'm first consuming all the pairs of the characters that I have. Now after placing all the characters, right, I'm being left with some odd frequencies. So let's say the odd frequencies are less than equal to odd length strings. Then I can simply take these odd frequencies and will fit in the middle of the odd length strings, right? And they will still be palindromes, right? I hope you are getting this. Now, what would happen if I have odd frequencies more than the odd length strings? Because see, the reason I'm able to do this like this is, the reason I'm able to say the odd frequencies will be left and they will be placed in the middle is because I can, perform that operation any number of times. Let's say I even form this a string and I have to, let's say, pick the middle and change it with another character. That also I can do, right? And after doing this, let's say I am given some odd length strings and some odd frequencies. So if this odd frequency number is less than odd length, then definitely I will be getting n number of palindromes only, because then there will be a way for me to fit in these odd frequencies somewhere and still get palindromes. But what if I have odd frequencies more than the odd length strings? That means I have consumed all the strings. Let's say this was 3 and this was 5, right? If there was such a case, so I would be having like this. Okay, I had these strings were there, 3 strings, and I have 5 odd frequencies that are appearing. So first I had already filled these, and then I filled the middle ones. But still, after filling the middle ones, I have 2 characters which have odd frequencies. That means I will not definitely not be able to get n number of palindromes. So I will have to take some string and place these characters in those strings and make it non-palindromic, right? That means I will have to compromise one string, because obviously there would be strings which will not be palindromes then, because these 2 characters will have to fit in somewhere. Now I'm left with these 2 characters, right? These 2 characters with odd frequency. Now I need to fit them somewhere. Now let's say, just like here, right? What we were trying to do in this case was, if we had pairs, right, we were trying to fit them in the smaller strings first. But now we have these characters, extra characters, which will definitely make a string non-palindromic. So do I start and put them inside of the smaller string or the larger string? Definitely the larger string. Why? Because see, if I put one character here and one character here, so these extra characters are making this non-palindromic, so my answer reduced to 1. But if I would have put these extra characters here, right, these extra characters here, then what would have happened? I would have 2 palindromic strings and 1 non-palindromic string. So my answer is maximum in this case, correct? So that means whenever I'm left out with extra characters, these remaining characters, I have to put it inside of the larger string. So that is what we are going to do. So I know if, so the logic is, I will first calculate the frequency array. After calculating the frequency array, I will also take a vector in which I will be storing the lengths of the strings. Now out of this, after I have formed this and this, I will calculate how many odd length strings are there and how many odd frequency characters are there, right? Now if these odd length strings are more than or equal to odd frequencies, then that means I can fit in these odd frequencies in these odd length strings in the middle character, correct? In the middle of the whole string. So that means I can consume all these odd frequency characters inside the odd length strings and get n as the final answer. That is, I can form all the strings in the given array as palindromes. But if this condition is not true, then I would be left out with some characters, right? So the remaining characters would be, the remainder would be odd frequency minus odd length. If this is not true, if this is not true, this is not holding that odd length is greater than equal to frequency, odd frequency. Basically, if odd length is less than odd frequency, then we would be getting some remaining odd frequency characters, which I have to fit in some string. So what we would do, let me first write the remaining number of characters. The remaining number of characters would be odd frequency minus odd length. All right, and we will try to fit in these remaining characters in the larger strings. Let's say I try to fill in here, let's say these odd number of characters were 10, right? So I only have 3 in the largest string, so I can take these 3 characters, fit in, but 7 characters are still left. Then I would go to the second largest string and try to fit in these remaining characters in that string, and we will keep on moving. And in this way I will be also reducing my answer. So initially I will take my answer equal to n, because if even this condition is true, right, that odd length is greater than odd frequency, our answer will still be n. But it will not be n when odd frequencies, some odd frequencies are left out. So we'll calculate the remaining odd frequencies, and what I will do, I will iterate. So first I'll take the largest string, right? So I'll sort this length in decreasing order, and I'll iterate here, and I will take the answer and I'll reduce the answer as n minus minus as I consume all these characters here, right, in the largest string. And I'll keep moving forward from the largest to the second largest, third largest, and so on, and keep reducing this n or answer. So I hope now I'm able to make my solution clear. Let us go ahead and look at the code, then it will be more clear to you. So what I'm trying to do, I'm taking word size inside of n, then odd length and result. So result I am initialized to n. Why? Because this can be the maximum that I can obtain. Then I'm making lengths and frequency array. So I'm iterating inside of each word, and I'm taking the length of this word, right? And then we are putting in inside of lengths array. After that we are checking if this length, this particular length that we put inside here, is it odd. If it is odd, then we will increase our odd length counter. Then we are iterating here, and we are iterating in every word, and I am making this frequency array. After doing this, I am taking this odd frequency variable, and in it I am taking the number of frequencies which are odd. After doing this, I am calculating if there are any remaining frequencies. So as I said, if odd length is greater than odd frequency, correct, that is the number of strings which have odd length are more than the number of frequencies which are to be consumed, odd frequencies which are to be consumed, then definitely I can consume them and place in the middle of the odd length strings, right? But if this is not true, then I will be getting some remainder, and that remainder would be at odd frequency minus odd length strings. So that I'm taking here. Then I am sorting the lengths array, and I am sorting it in decreasing order. After that I'm simply iterating here. Now what I'm doing is I am iterating inside of these lengths, and also until I have remaining number of frequencies. And then inside here I am calculating lengths of I, that is I'm taking the length of that particular word, and we are removing these many elements. Now why have I taken this here? I have taken this here because initially what we did was we assumed that we have already tried to form the strings like this, right? We have already tried to form the strings as palindromes. After forming the strings as palindromes, see what happens when there is odd string. I have already consumed a odd frequency here, so that is why I'm also removing the length from lengths, this odd frequency. If the lengths, see, when the length is odd, I would be getting 1 here, right? That means I have consumed an odd frequency here also, right? So I have to remove that frequency. And if this is divisible by 2, that means I get 0 here. I get 0 here. That means I tried to fit in pairs, right? And no odd frequency was consumed here. So that is why I'm taking this, right? So that means one character I am assuming that while forming the palindromes, I took it at the middle index. But because I cannot form all the strings as palindromes, I have to take this largest string, and what I have to do is I have to remove the lengths. But if it is odd length, then I assume that I have already taken the odd frequency inside the middle element, right? So I'm removing that as well. So this is how I'm and then let's say if the odd length is there, so I'm removing length minus 1, and if the string is of even length, I'm removing all the characters. Then I am removing whatever is the length according to that, removing the number of odd characters I consumed in this string and putting it in remaining. And then I am also reducing one string because I have put all the odd frequency characters here, and that have made this string non-palindromic. And after that I can simply return the result. So this is basically what we had to do in this question, right? So let me quickly sum it up. What I'm trying to do is I'm first trying to form the frequencies, right? I have formed the frequency, I also formed the length, right? I also formed the length. Let me write it with a different pen. Okay, so we have frequency array made, we have lengths array made. After doing that, we are calculating what are the amounts of frequencies we have, then what are odd length strings are there, how many odd length strings are there, right? And then we are assuming that okay, I have consumed maybe all the pairs, now I have to place these odd frequencies inside of these odd length strings. So then if the odd frequencies if odd frequency is less than equal to odd length, then that means I can consume all these and put them inside of the middle index in these odd length strings. That means the answer will still be n. But let's say these odd frequencies are more. That means I cannot fit in the all the odd frequency characters inside of odd length strings, right? That means there would be some characters remaining, and that would make, if I try to fit them in anywhere, I would be making them non-palindromic, right? So if I'm making them non-palindromic, so I said start from the largest strings, right? Largest length string. Why? Because if I start with the smaller strings, then we would not be getting maximum palindromes then, because in the largest string, if I take 4 characters, right, and here we only have 2 characters, so I'll be consuming these 2 strings and the answer would become 1. But if I place all the 4 odd frequency characters which are going to make the string non-palindromic, then one string will be non-palindromic but 2 strings will be palindromic, so still the answer will be maximized, right? So that is what we are doing. Consume in reverse or from largest string. And another thing that we saw was, because we initially had said that, see, because we had some odd frequency and odd length, right? So as I said, here we considered, right, let's say we only have 3 strings, right? And we have consumed odd frequencies here, here, but still 2 frequencies are left, right? So because I had already assumed that I have placed one odd frequency inside of an odd length string, that means when I will be removing it from the remaining, right, I cannot remove all the characters. That will give me a wrong answer, because I assumed that I have placed one character in the middle. So in case the string is odd, right? So what this is doing is, in case the string is odd, please remove that middle index, right? That is one character where we already had inserted the odd frequency. But if the string length is even, that means we were only considering characters and pairs and not odd frequency characters. So that is another thing that we did here, and that is the basic logic. And based on that, after consuming these characters, right, I'm also checking here if remaining characters are there or not. If there are no more characters, then we can return the result. But if there are characters, we will consume it in that string, and we will also reduce the number of strings that are palindromes, right? Initially it is n, and will keep decreasing unless and until these remaining characters are not consumed. So that is the whole logic, and that is how we have to solve this problem. Now let us talk about the time and space complexity. So you can already see the space complexity here would be the size of the words array, because we are storing the lengths of the word. Then time complexity will be n log n. Why? Because we are sorting here, right? And here it's not n cross m, because see, the words length can only be up to 100, right? And so basically that's very less, right? So I can consider this is This is one iteration only, right? So that's it. That's the time complexity and space complexity. And I hope you understood how to solve it.